So welcome back, students. Now after I completed the properties of lithium and its anomalous property, diagonal relationship with magnesium, now I'm coming to the topic sodium. Sodium I've already taught the preparation methods we have already studied, that is by two methods. Now apart from that, we are going to study the important compounds of sodium which is prescribed for your NCERT syllabus also. What is that? Sodium is going to show us different types of the important compounds of sodium are. First is you're going to study about caustic soda, that is sodium hydroxide. You'll also be studying about your washing soda, that is sodium carbonate decahydrate. Okay, that means 10 water molecules of crystallization. After that, you'll be studying about baking soda, that is sodium bicarbonate. The most important concept on peroxides also you have. Yes, the most important topic you need to remember is we'll be studying with the formula, that is easy. Preparation also is easy. Physical properties, nothing much to remember. But chemical properties is where you'll be questioned. You'll be asked different chemical reasoning questions in the chemical properties. I'll be doing one after the other. Yes. So now let us start with the formula. So the first compound of sodium which we're going to study is caustic soda or sodium hydroxide. So when I have to speak about this caustic soda or sodium hydroxide, I'm going to prepare this by a method called electrolytic method. That electrolytic method we are going to use mercuric cell. So in the electrolysis, which electrolysis I'm performing using, I'm going to do the electrolysis process of sodium chloride, that is aqueous. So what are we going to do? I'm going to directly write the reaction now. So what happens? First you're going to take sodium chloride, you're going to dissolve it in water for the electrolysis to happen. So when this dissociates, you're going to get three important products. 1, 2, 3. One at the cathode and the other two at the anode. Remember that. First you're going to get hydrogen gas which evolves at the cathode. Remember this. After that you are going to get chlorine gas as well as your sodium hydroxide. These two you will be finding it deposited at the anodic compartment. Right, now let us balance. Now here hydrogen 2 plus 2 hydrogen. Okay, let us start with chlorine. Chlorine is 2, so I'll put 2 here. Done. Now here when I have to speak about hydrogen, okay, when chlorine is 2, sodium also has become 2, so I'll put 2 here. But hydrogen is 2 plus 2, 4, so I'm going to write 2. Now it's balanced, isn't it? So this is the preparation method of your sodium hydroxide caustic soda. Done. That is by electrolysis. Now when I have to speak about the properties of sodium hydroxide, basically sodium hydroxide crystals, they're white crystals, isn't it? Right? So let me write the physical property as they are white crystalline solids. White crystalline solid. Okay, so now what is the specialty? Whenever I say crystal, we are going to speak in terms of water of crystallization, isn't it? Yes. So this sodium hydroxide crystals are deliquescent in nature. They're going to absorb moisture. So the first important second property is they are deliquescent. Now when I take the sodium hydroxide crystal, when I dissolve it in water, it immediately dissolves in water, right? So when it dissolves, after dissolving, then what we call this, then base dissolved in water is called alkali, isn't it? That alkali now is very corrosive in nature, right? So what should we write? Sodium hydroxide immediately dissolves in water or is soluble in water, dissolves in water. So what solution does it form? It forms an alkaline solution. That alkaline solution, when you see, they are very corrosive in nature, right? Corrosive means, I think it will corrode the very, concentrated rather, right? So corrosive means eating up of, correct? Yes. Now along with that, if I have to say, sodium hydroxide caustic soda is soapy to touch, bitter to taste, right? All these are different properties. So there you can also include that, the soapy to touch, the bitter to taste, right, to taste. Okay, simple important things. Now apart from this, now the actual concept of your sodium hydroxide starts. Let us start with the chemical properties. One question, one reasoning we have. Let us reason all those. Right, so when we come back to the chemical properties of sodium hydroxide, as I said, many reasoning questions are asked from this. Means you should know the concept of this particular reaction. Then it's easy for you to mark the multiple choice question, the correct option in the exam. Otherwise, there will be negative marking. Be very careful, right? So when I have to speak about sodium hydroxide reaction with halogen, right? Let us speak about chlorine rather, right? So very important thing. What should you remember? There are two conditions: cold conditions and hot conditions. Suppose if your sodium hydroxide or the caustic soda is reacting with, let me take initially the general reaction, X2, right? If it is reacting with X2 and the halogen, let it be chlorine here, this halogen is in cold condition. You're going to take the cold condition of that particular reaction. So then you're going to get three important products. What are they? The first product is 1X as NaX. The next compound is XO, and the next compound is water. Right. Now let me take this example. If X2 is chlorine, right? So sodium hydroxide, it's combining with chlorine here, and it is which condition? Cold condition, right? This is going to form a product. The first product, instead of X, you're going to write NaCl. Instead of this compound, you're going to write it as NaClO plus water is here. Now, what is this reaction? This reaction is called the disproportionation reaction. Disproportionation. I am always this reaction. Maybe the spelling is wrong. Okay, not a problem. Check it. So this disproportionation reaction, what is that? The same atom or the same element is going to undergo oxidation and reduction. The same will undergo oxidation and the same will undergo reduction. How is this? Suppose here, what is oxidation state of this? This is 0. Here when I have to compare, this is +1, this is -1. Here when I check both the things, I am going to get +1. Now what is happening? From 0, there is increase in oxidation number. Increase in oxidation number is nothing but oxidation. Here from 0, there is decrease in oxidation number. That is nothing but reduction process. This is reduction. Now there's such reactions where the same element undergoes oxidation as well as reduction is called disproportionation reaction. Remember this. Now condition 2, this is, let us write, this is case 1, let us take case 2. Now what am I going to do? Instead of cold conditions, I'm going to take hot conditions. Now what am I do? NaOH plus this is halogen. Now the condition is hot. Now you have to be careful. In the exam you need to observe carefully whether they've given you cold condition or hot condition. Now the product which is going to form is NaX is the same. Instead of NaXO, you're going to get here NaXO3 plus water molecule. Let me write in terms of X now. X2 is chlorine, so substitute. This is also disproportionation, NaOH, this is Cl. Now you're going to get hot condition. Here instead of NaX, you're going to write NaCl. Instead of NaXO3, you're going to write NaClO3 plus water molecule. That's it. So this is the most important, same product. This is different, this is same. So this is how you're going to remember. Reaction of sodium hydroxide or caustic soda with hot and cold chlorine is a type of disproportionation reaction. What is that? In which both oxidation as well as reduction occur in the same reaction. You need to be very careful when such reaction is given to you. So let us come back and do one more reaction with the reasoning question. Right. Let's come back and see the next reaction. Here, what is this reaction? Here we are going to react sodium hydroxide or caustic soda with metal zinc oxide. Right. So now dioxide rather. So what should you remember? The most important concept here is we have studied in grade 10. What is this? Base plus metal gives me what? Gives me salt plus hydrogen gas. This is what you have studied. The same thing I'm applying here. So here when sodium reacts with zinc, it's going to form a salt, that is sodium zincate, Na2ZnO2. What is this? This is called a salt of this. It is called sodium zincate and hydrogen gas as usual. Simple reaction, isn't it? Right. So they may ask you the product, they'll give you the product, they'll ask you to identify. Now, when I have to come back to reaction with silicon dioxide or silica, sand, here there are two conditions. Remember, the first condition is what will happen when, they may ask you directly, what will happen when your hot and concentrated sodium hydroxide or caustic soda reacts with sand? This is how they may ask you. So suppose if I take sodium hydroxide here, the condition here is concentrated and it is hot. This is the condition. Now this is reacting with silica SiO2. Now the temperature, you should remember, it's almost 900 degrees centigrade. 900 to 1000 degrees centigrade. So now what is it going to form? It's going to form sodium silicate, NaSiO2. This is called sodium silicate. Sodium silicate. Right. Now the same thing, if I take sodium hydroxide instead of concentrated, if I take dilute, now it's going to combine with SiO2 silica. Now what is the product form? The product form, or this is no reaction. There is no reaction formed in this particular thing, right? This is where you need to remember. Yes. Right, now let's come back and see one more reaction that is with aluminium oxide or alumina or aluminium hydroxide. So what is the speciality of aluminium oxide or alumina? Alumina is an amphoteric oxide. This is what you have studied. Now what is amphoteric oxide? Amphoteric oxide is something which is going to react both with an acid and a base, isn't it? Now let's see. Now we are going to take a base, isn't it? Sodium hydroxide, and you're going to combine with alumina, Al2O3, or even aluminium hydroxide. Right, and now here it's going to form a compound. Okay, amphoteric oxide, as I said, it combines with both. This, when it combines with the base, it's going to form a salt. What is that salt? The salt is NaAlOH taken 4 times. Right, fine. So this is your complex salt, which is going to combine and form this. Now aluminium is 2, so 2. Sodium is 2, so 2. This is what is the compound formed. You remember this product now. Yes. So now next important thing, what do they give us? What happens when caustic soda reacts with zinc sulfate? They may ask you in this way. So caustic soda, as we know, sodium hydroxide. Sodium hydroxide, when it combines with zinc sulfate, simple, isn't it? Sodium sulfate and zinc hydroxide. Right, till now that is more than that we need to remember. So sodium Na2SO4 plus zinc hydroxide. Zinc hydroxide, the valency of zinc is +2, so 2. Hydroxide is -1. Right, now this zinc hydroxide, further if you treat it with sodium hydroxide, excess sodium hydroxide, if you're treating, it's going to form a salt, that is sodium zincate, again Na2ZnO2. Sodium zincate is the next important product form. So remember this. This is again one more important reaction which you need to remember. Right, now let us see the next question, next reasoning question of sodium hydroxide. If they ask you, can tin be dissolved in caustic soda? Yes, I'll say the answer is yes. What is the type of compound or product form? The product form is called sodium stannate. A coordinate covalent complex is formed. Let's see. Suppose when I take tin, Sn, I'm going to combine with sodium hydroxide. Here, what is the important thing? Here, you need to have this whole thing dissolved in water, aqueous solution of that, right? So now these two are going to combine. They're going to perform 2 important products. The first product is Na2, right? Sn inside the bracket, OH taken 6 times. This is called sodium stannate. Sodium stannate, right? Along with this, you're also going to get the leftover hydrogen gas. Remember this. Now let's balance. Now sodium is 2, so 2. Now here hydrogens are, if I have to take 2 plus 2, 4 only. Fine. So now what happened here? OH is almost 6, isn't it? So what should I do? If I have to place this 4, okay. Now see here 4. Now let us place 4. Now 4 2s are 8, 9, 10. Correct. 4 2s are 8, and the complex, yes. 2 4 2. This should be 2 only, isn't it? Now this is right. 2 2s are 4 plus 6, 10. 4 2s are 8, 8, 9, 10. Right? This is the balanced reaction. That is your sodium stannate. Now second reaction. Reaction with FeCl3. In this reaction, what is this type of reaction called? This reaction is called double replacement reaction. Double replacement reaction. Simple. Nothing big in this. So sodium hydroxide, you're going to dissolve it in ferric chloride. What do you get? You're going to get NaCl and ferric hydroxide. So what is the valency of this in ferric? I said no. So it is FeOH taken thrice. Ferric. Okay. Then NaCl will be the leftover product, NaCl. So 3 chlorines, I'm making this 3. Here I'm 3 sodiums, I'm making this 3. Now hydroxyl group is 3. 3 already. Fe is 1. 1, NaCl is 3, 3. So this is the balanced equation for the reaction between ferric chloride and sodium hydroxide. Very important, sodium stannate. Please memorize it. Practice it more number of times. You will get the reaction. Right. Now let's come back and see this reaction. So in this reaction, what is the importance of this reaction? Here you need to remember what will happen when sodium hydroxide or caustic soda reacts with carbon dioxide. Here there is a difference in pH which you should remember. What is that? In this first case, the pH, if the pH is less than 8, that means it is a dilute solution. Now in this particular case, if the pH is greater than 10, what will happen? Right, there are two ways or two different products formed. You need to be careful in the given option in the question. What is this condition? When the pH is very less than 8, that means you're going to pick up a dilute solution of sodium hydroxide. Here, if the pH is greater, that means you're picking up a concentrated solution of sodium hydroxide. Let us see the products formed. First of all, this carbon dioxide, it's going to react with sodium hydroxide, I said. Right, now what is this? This is dilute. But here, the most important thing, this is not going to directly form the product, but it's going to undergo two steps. In the first step, this is going to form carbonic acid, right? So this here H2CO3 carbonic acid. Now in the second step, this carbonic acid is going to combine further with your sodium hydroxide. Then it forms sodium bicarbonate, that is your baking soda, as well as water molecule. But when it comes back to your pH greater than 10, this carbon dioxide directly combines with sodium hydroxide, same thing. Now, instead of carbonic acid, here the product formed is this directly because the pH is very high and it is concentrated in nature. This sodium bicarbonate now further combines with your caustic soda, sodium hydroxide, and you're going to get a product that is Na2CO3, sodium carbonate, as well as Na2CO3 is out and water molecule. So this is where you need to be careful in defining or finding the product. Less than 8, these are the products. Greater than 10, concentrated, these are the products. Right, now let's see this reaction. That is reaction with carbon dioxide. Now what should you remember in this? So whenever a carbon dioxide is reacting with caustic soda, there are two important conditions which you should remember. What is that? It can be dilute sodium hydroxide reaction and concentrated sodium hydroxide reaction. So when I have to speak about dilute sodium hydroxide, in the exam if they give you a condition that if it is pH is less than 8, remember, if the pH is less than 8, that means I'm going to give you, or we are going to pick up dilute solution of sodium hydroxide. If they're giving you concentrated, that means the pH is greater than 10. Right? Fine. So remember this. Now when I take this carbon dioxide with dilute, it will not react directly. First important thing, it's going to combine with water and form carbonic acid. Now this carbonic acid is going to combine with your caustic soda and then form products. What is the product? It's going to form NaHCO3, that is sodium bicarbonate and the leftover water. NaHCO3 and water. That's the first important thing. Now when you take the concentration of sodium hydroxide higher, that means concentrated, your carbon dioxide directly combines with the sodium hydroxide concentrated. And what is it going to form? It's going to form sodium bicarbonate, NaHCO3, NaHCO3. Now this sodium bicarbonate is going to further react with this caustic soda. Concentrated, isn't it? It's going to react further and it's going to form a product that is Na2CO3, sodium carbonate, and the leftover is water molecule. So this is where you need to remember the product. If it is lesser than that dilute solution, the product form is two-step. This is also two-step, but in the first one, sodium bicarbonate is formed in the second step. In the second case, sodium bicarbonate is formed in the first step only. Right, now when I have to do the next reaction, what is this reaction? Reaction with carbon monoxide, simplest reaction, right? Let's see. When sodium hydroxide reacts with carbon monoxide, it's direct addition, nothing to do. HCOONA. Sodium formate is a product formed. What is this? It's going to form a product that is sodium formate, nothing else to remember. But here, this is important now. What is this? When I'm going to take caustic soda, that is sodium hydroxide with sodium sulfur dioxide, here also direct, nothing to do, addition. Here, just see here, Na2SO3. Na2SO3. Let me write that. Sodium sulfide. Now sodium is 2, so I'm going to write 2 here. Right. So along with that, water molecule also is here. Done. But now what is important? When it reacts with sulfur, this is where you need to be careful. When it reacts with sulfur, right, the colloidal sulfur, this particular reaction is called disproportionation reaction. The same thing which we did, where same sulfur is going to undergo oxidation as well as reduction in the same reaction. What is this? The first product which it forms is sodium sulfide, Na2S. The next reaction or the product which is going to form is sodium sulfite, Na2SO3 and water molecule. Now let us see. Here the sulfur oxidation state is 0. Here when I have to take Na2 is +2, so this becomes -2. Now in this case, when I calculate, this is +4. Now see, from 0 to 4, increase in oxidation state. So this is oxidation process, oxidation reaction. Here from 0 to -2, it is decrease in oxidation state. So this reaction is called reduction. Both oxidation and reduction is happening in the same reaction. So this type of reaction is called disproportionation reaction. Yes, so very important reaction. Please try to memorize it.